Here's the answer to the quiz on the 24th of July. So this is a 53-year-old male who presented with multiple soft nodules behind the right knee, which he noticed only progressing over the last 3 years, which was the unusual part of the history. If he had said he'd had this all this life, I probably wouldn't have taken a biopsy, but he remembers only a single papule the size of something like that since childhood, and then all these new ones came up fairly recently in the last 3 years, and he said they were slowly growing. Now, let us look at the histology. Now, clinically, I thought these were neurofibromas because they're quite soft and multiple of them, but he had no other history suggestive of neurofibromatosis, no family history, no other cafe-au-lait spots or anything of that sort. Now, histology on low power, this is the entire lesion, it's a excision, small punch excision of one of the smaller lesions, shows a relatively well circumscribed, but it looks like it's unencapsulated tumor composed of spindle cells extending from the sort of mid-dermis to the lower dermis. Now, on higher power, what you can see is these spindly cells, slightly wavy nuclei. You can see that spindly cells with wavy nuclei arranged haphazardly. They're not forming any fascicles or bundles. And one more clue is that there is no clefting in between, and I'll tell you why that's important. A few blood vessels spanning through, and I even given you the higher power images. So these are spindle cells with slightly wavy nuclei. So the nuclei are not straight; they're sort of waving around a little bit. And the clue here is a sort of the stroma, which appears a bit pale, and this is what we call a sort of a myxoid stroma. And what you see here is a mast cell, all right? So these are nerve cells, actually, or Schwann cells, and the mast cell is a clue because mast cells are present, though not specific to neurofibromas, are present wherever there is sort of a myxoid stroma, and that's why you have them more often in neurofibromas, because neurofibromas often have a slightly myxoid stroma. When the stroma is very prominent, you call it a myxoid neurofibroma, but in general, myxoid is part and parcel of a neurofibroma, but it's just the extent of the myxoid background that determines whether you call it a myxoid neurofibroma or not. All right. Now, I often get very confused, and therefore I put in all these differentials. But basically, this is a nerve cell number one, and this is a mast cell. So we'll go over to the differentials. Now, histioid Hansen's, well, I think you can exclude that based just on the history, actually. But histioid Hansen's does not have these sort of nerve cells, mast cells, unusual, and usually it's much more, has more of a collagenous background slightly, and has histiocytes. Now, these are not histiocytes. Histiocytes, remember, I told you have a slipper-shaped nucleus. Yes, they can have spindle cells, but you do see some histiocytes in the background, which give you a clue. And the other thing is that it's not such a dense nodular perforation in histioid Hansen's. Often you see the sort of coursing through the neurovascular bundles, which is evident even at least in some sections. And as I told you, you do see other inflammatory cells. It's not just these sort of spindle cells that you see. Now let's go to the other differentials, which I've put in here. So schwannoma, which a lot of you have thought this may be, usually has these typical cellular and hypocellular areas, which are described as Antony A and Antony B, usually has a capsule, some microcysts. Now, Antony A refers to these sort of dense cellular areas, which have, in some places, the nuclei tend to form palisades. You can see here the palisading around the central area. Now, the central area is nothing but the cytoplasm, which is eosinophilic. So when the nuclei are pushed towards one side and the cytoplasm is all concentrated in one side, this is called a Verroque body, and this is called palisading of nuclei. This is typically seen in the cell-rich Antony A areas. Antony B areas are sort of more in a loose stroma. When you see these nuclei set in a loose stroma, you call them Antony B areas. So basically this biphasic pattern where you have Antony A and Antony B areas, Antony B are the hypocellular and Antony A are the hypercellular areas, you think about a schwannoma. All right. Now, the other differential I get very confused about is a neuroma. A neuroma may be capsulated, actually more often, but sometimes unencapsulated as well. What you see in a neuroma, which is typical, is these sort of fascicles. The nerve cells tend to form fascicles, okay, and in between the fascicles you see this clefting, and these you don't find in a neurofibroma. Okay, the neurofibroma is much more haphazardly arranged nerve bundles, while this is they try to form fascicles. You can see here the fascicles trying to form. You see higher power, the nerve bundles try to form fascicles. Much more wavy nuclei you can see here, but that isn't really the differentiating factor. The fact that they're trying to form fascicles and this clefting in between the fascicle bundles is the clue. I use mast cells as my clue as well. Often neuromas don't have a myxoid background, quite more densely cellular, and don't have a myxoid background. Therefore, you don't see the mast cells. So this is an example of a dermatofibroma, much more fibrous background. You can see here, much more collagen. You can see here, and this is what we call a storiform pattern. A storiform pattern is not exclusive to dermatofibroma or fibrous histiocytoma, but often seen. Often you see this characteristic entrapment of collagen, where you see this collagen which is quite thick, swollen, and surrounded by a few fibrous histiocytes. You can see that here. Okay, and this is often seen in the periphery of the tumor. So this is a dermatofibroma. These are not nerve cells. The cells are not wavy. The nuclei are not wavy here. They're sort of more just spindly shaped. Don't see the wavy nuclei of a neuroma or a neurofibroma. And this is just another example of a cellular dermatofibroma. You can see the higher power view of the cells. These are fibrocytes. They look more like histiocytes because they have this sort of slipper-shaped nucleus, but much more eosinophilic cytoplasm, which histiocytes don't have. This is a typical example of a leiomyoma, and here you see this much more eosinophilic background cytoplasm, which cigar-shaped nuclei, which are basically thick nuclei with, which are much paler in color, and you can see that they're cigar-shaped, thicker, and much more straighter. They don't have the wavy nuclei of a nerve cell. Okay. So I hope this explains all the differentials. Glomus tumor is pretty easy. There's a glomus cells around more cellular. Kaposi sarcoma, much more pleomorphic, and you see lots of blood vessels which are malignant. You see reduplication of the endothelial lining, etc., which is absent here. And I've discussed pretty much everything else. All right. Thank you very much for your attention. I hope you enjoyed the quiz.